Good morning, sir. The co-host right has been given to you. So can you please check whether the presentation is visible?
Hello.
Hello, am I audible, sir? Hello. Am I audible, sir?
Now you are audible.
Sir, co-host right has been given to you. Can you please check whether the slides are visible?
Slides. Has anyone shared the slides?
No.
You want me to share the slides?
Yeah, I mean, if you are going to present through slides, kindly check.
Yes.
Otherwise, this is also okay.
Can you see the slides now?
Yes, sir. Yes, sir. They are visible.
Okay.
Okay.
So
Yeah, we'll just begin in a few minutes. Kindly give us 5 minutes. We'll just begin.
okay.
Good morning to one and all present. I warmly welcome our today's expert, Professor Dr. Manas Behra, and all our participants. We will begin our today's session with a short introduction of our expert. Professor Manas Behra is currently working as an associate professor in Department of Ocean Engineering at IIT Bombay, India. Sir has completed his BTech in Civil Engineering from Veer Surendra Sai University of Technology, Odisha, MS and PhD in Ocean Engineering from IIT Madras. He has a vast experience in the field of research and academics. He has over 20 plus research publication and 7 books in his name. Sir has been honored with various awards. To name a few, Professor R.J. Garde Research Award 2018 by Indian Society for Hydraulics, recognizing the contributions in the field of ocean and coastal engineering. Best Paper Award in the 15th Congress of Asia Pacific Division of International Association for Hydraulic Research in the year 2006. Gold Medal for Best Civil Engineering Graduate for the year 2003. With this short introduction, I would now request Sir to begin with the today's session. Over to you, sir.
Okay. Thank you for the kind introduction. Sorry, I did not get your name. So can you tell your name, please?
Yeah, myself, Mrs. Aboli Ravikar from Civil Engineering Department.
Okay, Mrs. Abuli, thanks for the kind introduction, and thanks for inviting me to give a talk to the participants in this seminar. And I would also be happy to take questions during the presentation as well as at the end of the presentation, if there are any. So my request to all the participants is to interrupt me as and when you feel you have some doubts. Don't wait till the end. And if you don't want to ask in between, you want to wait till the end, that is fine, but I'll go ahead with the lecture. So, Mrs. Abuli, I just want to know what is the overall schedule for this talk? Whether I will present for 1.5 hours, 1 hour, and then we'll take discussions, or what is the plan? Mrs. Abuli, can you tell
Ye-
me about that?
yes, sir. As per the schedule, the timings for this session is 11 to 1.
Yes.
So you can take as per your convenience. I mean, question session afterwards or in between.
Okay. So, fine then. Thank you so much. I will
Yeah.
start with the talk. If I see a lot of interactions happening in between, then we'll continue till the end. Otherwise, I'll give some time towards the end to take questions.
Yes, sir.
Okay. All right. So, again, good morning, all of you, and welcome to this talk on recent trends and future scope in coastal engineering, which is a broad topic. Uh, there are many aspects of coastal engineering which can be discussed, and we can keep on talking for quite few days. But I thought for today's lecture, I will focus on various aspects briefly and give you updates of various research and various work that are being carried out in this field, as well as I will also highlight various future research that are being carried out or that are possible to be carried out by the uh, prospect researchers. So in this aspect, let me quickly give 1 or 2 minutes to quickly explain the ocean engineering group at IIT Bombay in the Department of Civil Engineering. So in Department of Civil Engineering, we have 7 different specializations. Ocean engineering is one of the specialization out of the 7. And in ocean engineering, we have 4 faculty members, and we mostly focus on coastal and offshore engineering aspects. Something that we miss here is naval architecture part, but most of the topics of ocean engineering, coastal engineering, and offshore engineering is covered by us. In addition, we have our master's program, MTech Ocean Engineering, and there are PhD students who are also joining with us in the Department of Civil Engineering and work with us in the areas of ocean engineering. So with this brief background about our specialization here at IIT Bombay. Yeah, so we'll start with the lecture. Now, coming to the talk today, when we talk about coastal engineering, many times we when we talk about coastal engineering, people take it as marine engineering. Then after that, they only think about the vessels and the movement of the vessels, but it is not like that. The moment we talk about coastal engineering, we are along the coast. Anything that happens along the coast is dealt by the coastal engineers and in the field of coastal engineering. That is something that you have already heard in the lectures that are given yesterday by 2 eminent speakers. And today you will also have another lecture in the afternoon. So instead of explaining on that, what is coast, what is the coastline, which I assume that you are aware of, we will straight away try to understand various processes that are taking place along the coast and what are the impacts or stresses that are coming due to those processes along the coast. Now coming to that, uh, yeah. So I'm writing coastal vulnerability because anything that adversely impacts the coast or anything that deviates from the natural process is vulnerable for the coast. So that's why if I look at the coastal vulnerability, what are the different factors that are going to affect the coastal vulnerability? If we see, you see here, you have waves first. Now, when we talk about waves, these are very good. We go to the beach, we enjoy with the waves, but the same wave, if it becomes very strong, they can affect us in various ways. So when I told us, that means it can be the coast itself, it can be the coastal structures that are present along the coast, it could be the coastal life present along the coast, many ways. So if we see wave impacts, there are number of places along the Indian coast where we have been hearing erosion taking place along the coast. So you will understand that in some of the field studies or case studies that will be presented possibly today afternoon. But the moment we have waves, this is a process which is going to carry the sediments, which is going to impact or which will put some forces on the coastal structures. So it is going to be understood and we need to analyze that. Next one is erosion and accretion that I said. So accretion is basically deposition of sediments. Erosion is loss of sediments. So when we lose some sediments or sediment is going to be removed from some location, we call the coast as eroded. If there is going to be deposition of sediment, we say that the coast has accreted or accretion has happened. Now, some people might think that erosion is a problem because you are losing the coast or you are losing sand from the coast. So some people might lose their houses, some people might lose their land, some places we may lose the beautiful beaches. So it is problem. But at the same time, if the sand is going to be deposited, it is not necessary that it is always good for us. We have a lot of facilities along the coast. We have ports, harbors. If there is going to be sand coming and depositing in those places, what will happen? With sand deposition, the depth is going to be reduced, or you will have less water depth available for the vessels or the ships to move. So we call that as draft. So now if the water depth is going to be reduced, it will hinder the movement of the vessels. Now that is also equally bad if it is undesirable. Some places we want the sediment to be deposited, some places we don't want the sediment to be deposited. So it is dependent on what we need at what place, and we define that whether it is adversely affecting or it is conducive for us. The next one is the sea level rise. So when we talk about sea level rise, it is basically linked to the climate change most of the time, and due to the global warming and due to the various processes that are taking place in the ocean basin. I'll not go deep into that, but when you have the thermal temperature or the rise in the temperature in the ocean basin, so there will be expansion of the waters, and that will lead to the rise in the sea level. I'm getting a lot of noise in between sometimes. Can I request others to mute, please? Thank you. So the sea level rise is also affected or is also influenced by the melting of glacier. So that is also contributing. So overall, what we are looking at is the effect of this sea level rise on the coast. So if there is going to be sea level rise, it will also flood certain areas along the coast which are possibly not being flooded at this point of time. So if the elevation is going to rise, So the future events like cyclones, when they come, they will flood much interior than what they are flooding now. So we need to investigate that also. The next one is cyclones, as I was discussing. The cyclones are frequent visitors along the Indian coast, especially along east coast of India. You have more number of cyclones compared to west coast of India. But in the given scenario of changing climate, the cyclones are also expected to be more in numbers along the west coast because the average ocean temperature of Bay of Bengal is slightly above 26.5 degrees. That is the threshold for cyclone generation. Now, if the temperature is more than 26.5 degrees on an average in an ocean basin, that basin will be able to create more number of cyclones. So Bay of Bengal is conducive for that. Whereas Arabian Sea used to be less than 26.5 degrees for most of the time. That's why we used to get less cyclones in the Arabian Sea. But now with the global warming, the temperature in the Arabian Sea is also reaching to that threshold where the number of cyclones are going to be more. And if that happens, then the cyclones that are affecting the west coast will also increase. So eventually we need to understand that and how these cyclones are affecting the coast. It is affecting in multiple facets. First of all, when the cyclone comes, it brings high wind speeds. It will damage the coastal region because that is the first layer of obstructions the cyclone is going to face. So the impact is going to be very high. Then second, it is also associated with the storm surge. When the cyclone heavy wind is coming from the sea towards the land, it is also bringing a lot of water with it and it will be pushed inside the land. So the storm surge that we call is also going to flood the coastal regions. So that also we need to understand. Next, the cyclone also brings heavy rainfall. So due to heavy rainfall, this flood which is coming from the seaside is also going to be associated with the rainfall that is going to come, and it will also lead to a lot of land-based runoff. So the land overland flow is also going to be superposed on top of this uh, flood that is entering from the seaside. So eventually, this coastal region is going to be the area where the water from the land side is going to be pushed and from the seaside is going to be pushed. So this will be heavily flooded. So that is why that is going to severely impact the coastal region. So we need to also understand that aspect. The next one, as I have already explained you, storm surge flooding, which will happen due to the cyclones. Next, sometimes the coast is affected due to the tsunami. And those who remember the past tsunami event that has affected India quite a lot was in 2004. And the tsunami that was generated somewhere close to Andaman coast or Sumatra coast. So that tsunami propagated and has affected most part of the east coast of India. And to some extent, it has also affected the Kerala coast after it really turned or refracted over the southern tip and it has reached the Kerala coast. The tsunami is also another event which can affect the coastal people and it can be vulnerable. And when there is a tsunami, the characteristic of tsunami is completely different. It brings completely different kind of momentum, huge momentum of water, and it can completely wash away everything that comes in front of it, including ships, large ships to small vehicles, whatever it comes. So it can completely wash away. So the power of tsunami is also very, very important to be considered when we design various coastal infrastructure. Next, we have coastal infrastructure. So when we are working on the coastal infrastructures are the major, what is the major components that are linking us from the land to the sea. in various ways. So we have maritime facilities. So the vessels are moving, or we have commercial ships, we have passenger vessels, we have small boats, we have medium fishing vessels. All of them will depend on some facility where they can actually come and land. It is like parking space for them. So the facilities we have different ways classified. We have ports, harbors, fish landing centers, fishing harbors. We have jetties, passenger jetties. We have ro-ro jetties where there are vessels where we can put our car and the people can also board on that and they can move. So in the recent days, Government of India is giving a lot of push for this inland water transport as well as the coastal transport. So now to decongest the traffic on the road or along the coastal roads, the water transport is being encouraged. So under that aspect, lot of developments are taking place along the coast. So number of passenger terminals, jetties are being constructed. And it is not only for the convenience alone, it also enhances and improves our tourism aspect. So, so both ways, it is going to be beneficial for us. But at the same time, when we are constructing some coastal infrastructure, it is also necessary for us to understand, are we affecting the natural coastal processes in any way? If we disturb somebody, obviously somebody will also reciprocate and disturb us. So if we disturb the sea will disturb us. So that needs to be investigated and studied before we implement any kind of infrastructure along the coast. So that is very, very important. Next, the last one that I want to keep and I don't want to miss that is the coastal water quality. So coastal water quality is very important because whenever we go to a beach, let us say first, let us be selfish. Let us think about us. We go to the beach for our tourism purpose, for recreational purpose. If the water quality is bad, then obviously we will not be interested to go to that beach and take a bath or get into the water. So we need to ensure that the water quality is good. Second, when you spoil the water quality, it is also going to spoil the marine life. So there are a lot of fish, lot of marine life, some of the marine plants or corals that are going to grow in the coastal waters. So in such cases, if the water quality is going to deteriorate, then these aspects will also be affected. So the fish will possibly die, the corals will be lost, they will also die. So it will affect in various ways. And in addition to that, the coastal population will also be affected due to the water quality, which will affect their livelihood and their uh, fish catch and all the facilities that they are getting. If tourism deteriorates, they will get loss of economy, and that is going to adversely impact. So these are various stressors I wanted to first highlight. Now, let us move to some of these aspects where I will try to tell various research or various studies that have been carried out. So now, uh, yes, is anyone telling something? Okay. So if not, I think, okay, just give me a second. I, I think there are a couple of slides which I had hidden that, but now I can actually open it up. So just give me a few seconds that is required for me. I forgot to unhide this slide. Yeah, all right. Okay. So Now, let us move to the cyclones first. Yes. So now let me talk about the cyclone impact first. So here, what I'm trying to highlight is the climate change impact on cyclones, storm surge, and coastal flooding. So when we talk about climate change impact, it is basically the long-term change that has happened on the number of cyclones that are taking place and how the intensity, how the frequency have changed over the period of time. Now, if we look at that, you can see this left side figure shows us a map that depicts the cyclone tracks of the tropical cyclone tracks in the northern Indian Ocean, especially the Bay of Bengal and the Arabian Sea from 1970 to 2019. So last 3 years are not included in that figure. However, if we look at the number of cyclones, you can clearly see that Bay of Bengal shows you more number of cyclones compared to Arabian Sea. And there are situations when there have been two cyclones simultaneously in both the basins. In the year 2018, there was a cyclone Titli on the in the Bay of Bengal and cyclone Luban in the Arabian Sea. So both these cyclones occurred at the same time in both the basins. So just to highlight what is the significance of that, why I am talking about two cyclones happening same time on both the basins. Usually that's not a normal circumstance. So usually the cyclone happens to release the energy, excess energy from the sea. So the sea is trying to release its excess energy concentrated, and that will be dissipated in the process. Now, most of the times, either the cyclone gets generated in the Bay of Bengal or the energy is concentrated in the Arabian Sea and that gets generated and propagates. But if there are two cyclones simultaneously in the both the basins, that means the intensification of this energy or concentration of energy in this ocean basin have become really severe. So that is how both the cyclones have occurred at the same time, and both of them are intense cyclones or very severe cyclonic storms. So that is what is the significance of this two cyclones occurring simultaneously in both the basins. Now, if we look at how these cyclones have been occurring in different ocean basins, you can see in here in this figure, you have Northern Indian Ocean or North Indian Ocean, North Atlantic, Northeast Pacific, Northwest Pacific. Then you have Southern Hemisphere. These are the major cyclonic uh, basins where most number of cyclones occur. Now here you can see here the percentage of cyclones in each ocean basin. Okay. The percentage wise in the Indian Ocean, it is much less compared to other ocean basins. You can see the numbers here are 1,600, 500. Here it is close to 200 only. But why it is important? Because the number of population affected by these cyclones along the North Indian Ocean basin are very high. It is more than all the other basins together. So that is why these cyclones are very, very important, and these basins are very important to be studied. And when we look at 6% of the cyclones are in the Northern Indian Ocean basin, and these 6% cyclones are responsible for more than 80% of the global fatalities that are taking place due to coastal flooding. So now comes the point why this is important and what are the aspects to be studied. So the moment we say there is a coastal flooding, it affects the livelihood of people, their loss of property, loss of business, everything is going to be shattered. And it is not only for the period of cyclone when it is occurring. When something is disturbed, it takes time to again regain back the momentum. So here, the job of coastal engineers come into play. What is our job? Our job is to ensure that this coastal community or coastal people are resilient against such kind of disaster. So how do we do that? That anyway, we'll keep on discussing during the lecture. But most important is we have to think that, okay, this many people are being affected and we need to do something for them so that they will be less affected or as minimum as possible, the impact is going to be there. How we can do that? Okay, there are a number of ways to do it. First, one may give the information of cyclones well before so that their damage, they can safeguard certain things and the damage can be reduced. Second, we can create some awareness so that they are aware that when they, yes, somebody is telling something. Is somebody telling something? No. Okay. I hope I am audible to everyone. Can somebody confirm?
Yes, sir. Yes, sir. You are audible.
Okay. All right. Thank you so much. So, when this kind of cyclones are going to occur, if we can have some kind of mechanism where the life of people will be saved, that is the first. Second, if the property of people can be saved, that is the next one. And in addition, there may be certain facilities which we don't want it to be affected in any case. So then we have to create some kind of protection measures for such kind of infrastructure. To give you an example, there was a tsunami in 2011 in Japan, and that affected their nuclear power plant, and due to which lot of radiation happened and a lot of people were affected due to the nuclear radiation. And it is not only temporary effect, the effect stayed for quite long, for number of years. And even now, the effect is there. So the point what I'm trying to mention is there are different requirements and different kind of protection measures or awareness or warnings to be provided by the coastal engineers. Okay. So somebody is talking. If there is a question, please ask. Otherwise, I request you to mute. Okay. Yeah. So now to look, looking at the intensification of cyclones in both these basins, you can see these plots of the figure on the right hand side. You can see here on the y-axis, it is PDI, power dissipative index of cyclones. So the power dissipative index in different ocean basins are shown in this figure. If you see that, as we see the power dissipative index in the Atlantic Ocean basin, let us say, was high in the years in the 90s, as well as it is high in 2010 and so on. But if we come to the North Indian Ocean basin, the power dissipative index was less in the 90s, 2000 and so on, even up to 2005. But from the year 2010 onwards, it has increased substantially. So it is clear that the power dissipative index means the intensity of the cyclones are increasing in this North Indian Ocean basin, that is Bay of Bengal and Arabian Sea. And if we look at this figure, which again, we analyzed that in the year 2015, and we can see here the PDI of Arabian Sea and PDI of Bay of Bengal. And both these basins are showing increase towards the year 2010 and so. So This clearly indicates that there is intensification of cyclones and the energy that is available in this ocean basins are increasing in the recent days. And this will lead to formation of stronger cyclones, and the formation of stronger cyclones will lead to more damage or more impact along the coast. So that is another area where a lot of work is required and people can study. Now, to give you glimpses of the catastrophic impact of the cyclones, you can see this slide where different cyclones are mentioned here. This is super cyclone in 1999. This is again same 99 super cyclone, how it has impacted. Then there was a cyclone in 2013, Philin. There are a number of cyclones which have been happening. Every year there is almost one or two cyclones. And just showing you a couple of cyclone impacts here as a typical damage that it creates during the cyclone. And this super cyclone 99 is the one where I was one of them receiving the brunt of the cyclone. So I know how it impacts and it devastates everything that you have. But in the duration last 25 years, especially after the 99 super cyclone, the mechanism to provide warnings or the warning system has been implemented by Government of India, and right now INCOIS is giving warnings for this storm surge, and IMD is providing the warnings for cyclones. So both of them together are giving the bulletins, and whenever there is a cyclone, almost every 6 hours, we get one bulletin which talks about the cyclone intensity, wind speed, area that will be affected, the storm surge that may take place, the regions which will be flooded. All these informations are given to us now. So the people which were affected earlier will not be so much at this point of time. Well, if all these things are done, then what is the role of coastal engineers even now? So still the scope for people is there, or the researchers are there. What is the scope? Now let us say, with all this forecasting, all the mechanisms where we do measurements, we have observations along the atmosphere in the ocean, then we do modeling studies of the atmosphere as well as the ocean, and we find out what is the cyclonic speed, intensity, the storm surge, everything through the modeling, and that we continuously validate with our observations. But now the models are developed to certain accuracy. So let us say the model output tells you that you will be the region will be flooded up to 2 kilometers from the coastline or shoreline. Now, if the inundation or the flooding is going to happen for 2 kilometers, what the government authorities have to do? The government authorities have to evacuate people in this patch so that they are not flooded and they are not in the flood prone region. So they will be moved to some places, designated places, which are pre-constructed and designed as per the standards specified by National Disaster Management Authority, and the structures are designed to withstand the cyclonic impact. So they are called cyclone shelters. Now these cyclone shelters will be there, which can accommodate almost 2,000 to 3,000 people at a given time, and the villages around that will be evacuated and they will be placed inside these cyclone shelters. So this has advantages in terms of the safety of people, and whenever there is a relief or support that needs to be sent by the government, it can be reached to the people at that designated places, so that it is well and good. But now point is, if we have given a focus that, okay, up to 2 kilometers it is going to be submerged, and it so happened that the water inundated up to 3 kilometers. So what will happen? The people from 2 to 3 kilometers who were not evacuated will be affected now. So that is something which is again dangerous. Similarly, if let us say instead of 2 kilometers, the water inundated up to 1 kilometer only, so the resource used to evacuate that 1 to 2 kilometer stretch is wasted. And more importantly, this sends one false warning to the people. The false warning means this time you evacuated them. Evacuation is not easy. It puts people in a lot of problem. They'll have to face a lot of hassle, and they have to vacate their houses and go there. So many problems. And with all that problem, finally, if they come to know that, okay, the water did not come to that place, so what will happen? They lose trust on these warnings that are being given by the government. So the accuracy of these forecasts are very, very important. So there is a lot of scope for people to work on improving this accuracy. Okay. I will talk about how these accuracies are being improved and what are the scopes that are still there. Now move forward. As I was telling about storm surge, so those who are little bit new to this field, it is basically the rise or fall, and rather it is considered as abnormal rise or fall of water in the sea generated by tropical storm over and above the astronomical tide. So we all know that there is going to be tide. So tide fluctuates every day. There will be high tide, there will be low tide. So this is basically the water level, excuse me, the water level variation that takes place over the sea. Now, on top of that, this tropical storm is going to push huge amount of water, and that will lead to sudden rise or fall of water during a short span of time. That could be few hours or half a day or so. Now, this storm or this water is being pushed by the wind forcing that is coming from the cyclone, and that will keep on gushing and inundating the coast. Now, let me take you to some equations. So far, you were looking at some nice pictures and movies and all that, but now let us understand some technical aspect of that. So when this wind is being pushed, what happens? There is the wind blows over the water surface. So there is the energy in the wind, energy available in the wind, and this energy is being transferred to the water surface. So we all have studied the shear stress that will be developed on any surface when there is a drag. So that you can see here, the wind stress, which is denoted by this term tau, is defined by this expression, which is rho a CD u square. Here CD is the wind drag coefficient. What is this wind drag coefficient? It is an empirical value which is computed, and that decides how much of energy is going to be transferred from the wind to the water through this parameter we are calculating as stress. Okay. So this wind drag coefficient is the density of air is same. You are not going to change that. Wind speed is same. So what possibly you can think that may decide whether that is the value that you are calculating is accurate or not is the wind drag coefficient. So wind drag coefficient is the major parameter or the important deciding parameter to tell whether you are accurately transferring the energy from wind to water. So now, in that case, there are a lot of formulations or lot of expressions which were given by number of researchers in the past. So there was one formulation given by Garrett in 1977, and this formulation is still being used by a number of forecasting agencies. Okay. So this Garrett's formulation is a popular formulation which is still being used by people. However, this Garrett's formulation, if you look at, this is giving some kind of uh, plot which basically tells that the wind drag. Now, if you look at the x-axis is your wind speed, y-axis is your drag coefficient, and with the increasing wind speed, the drag coefficient increases, and at some wind speed, the drag coefficient is considered to be same. It is not increasing further, even though the wind speed increases. Okay. Why it has been done like that? Because people found if you keep on increasing like this, then it like whatever is given by this expression by U, which is linearly increasing all the way, that is overestimating the uh, wind stress as well as the surge. So to avoid that, now people have given different formulations. Finally, the latest one in this series is 2012, that is by Gislema. And if you look at Gislema's formulation, this is slightly going up and then further it comes down. So the number of formulations are done. So now the idea is there are a lot of research which has been done and a lot of scope which is also available. So in this, our research group at IIT Bombay did one exercise, and what we did, let me explain it. So we tried to understand the physical process that is taking place along this boundary layer. So what is this boundary layer? Many of us are civil engineers or mechanical engineers or atmospheric science scientists. We all understand this boundary layer where the boundary is between the water and air. And the thin layer in between these two, or the intersection of these two, is called as boundary layer, where the variations or the processes are predominant. And all this energy transfer takes place through this boundary layer only. Now, how well we resolve this process and how well we represent in our model or in the drag coefficient, that will decide whether our values are going to be accurate or not. So instead of taking the drag coefficient directly, what we did, we used this wave boundary layer model, which basically considers the turbulent stress, wave-induced stress, sea sprays that are going to take place inside this boundary layer. Now, with this, I'm not going to explain this whole modeling process because that will take another 1 hour extra. So what I'm trying to tell in short, that with this, we are calculating a new drag coefficient value. Okay. So then initially we do a simulation using a model called AdCirc and SWAN. AdCirc is a circulation model, which basically gives you the U and V currents. Basically, in this 2D model, you have two horizontal dimensions, and both the current in both the directions are obtained from this AdCirc model, as well as the elevation, water surface fluctuation, that is also obtained from the AdCirc model. In SWAN model, which is wave model, you get the wave characteristics. What is the wave height, wave direction, and then wave period, all that you will get, because when you force wind, it will also generate wave. So through SWAN, we get the wave characteristics. Through AdCirc, we get the circulation characteristics. Now, by coupling these two, the impact of wave on the circulation and the impact of circulation on the wave is also modeled. So we basically try to come and simulate as realistic as possible. So in this case, we could simulate tide, circulation, waves, all that. Now, by doing it, we could get some kind of spectrums that are going to be there on the sea surface. So these spectrums are nothing but the representative conditions of the waves on the sea surface. Now, this spectrum is taken as input to this wave boundary layer model, and through that we resolve all these internal small scale physical processes and then come out with the drag coefficient CD. So this is CD, whatever we get is the updated CD based on the detailed processes that we have considered. And this CD is being used here again in the same AdCirc and SWAN model to get finally what will be the surge and what will be the inundation at some location. So this is how we improved it. Now, what did we do in this process? We basically increased the computation that we were doing earlier. Earlier, people were doing only this part. Okay, so this right side part, this part only people were doing. Now, so much of computational work is involved. Now, that is not acceptable for real-time forecasting and warnings, because you want to give the update to the people as quickly as possible. You cannot keep on doing research at that point. So what do we need to do then? We we have to develop some kind of empirical formulation for this drag, which will be better and which will be representative of this whole process that we are doing. So that is what next we tried. So I'll not get into the equations of all these models, that I'll leave it. Those who want to really work on these models and modeling part, they will go through that. And if you look at, there are number of terms here: source term, white capping, bottom friction, wave breaking. All these nonlinear terms are resolved and solved, and then we get the final output. So I'll not get into that part. Okay. Now, by doing that, we calculated the results for two different cyclones. One, if you could see here, we have considered two cyclones. One is Varda cyclone, one is Thane cyclone. And for both the cyclones, we tested how the results are improved. And we could find that the values that were given by IMD based on measurements at some locations, we could really capture those values based on this modeling that we did with this improved wave boundary layer model. Now, we also validated our water level elevations at various locations, at deep water locations, at shallow water locations. For both the cyclones, you can see here, this is at Ennore, and we could see at Ennore, let us say, when we compare different models with observations, the observation you can see, which is the black color, which is this dotted line. And as you see, there are number of lines: Woos method, LP is basically large endpoint method, Garrett's formulation, which I discussed, Chislema's formulation also I discussed. So among all these, you can see here the wave boundary layer model which we adopted. It really showed the best match to the observations, or the closest possible to the observation. And that is what is our requirement. So how accurately we can get the computations done, or the values can be obtained. The same thing we did also at other locations for different cyclones. So those who are planning to carry out future research studies, this is something very, very important. Whatever you do, you have to compare with some reference value. That reference value for your research could be from some experiments or from observations. So that is where you have to compare your values and ensure that what you are getting is correct, or how much error or bias you are getting from your modeling results, because modeling is always with some approximations. Okay, so similarly, we also obtained various statistical parameters: your root mean square error, the correlation coefficient, mean bias error, performance index, and all that we calculated for various methods. And all the methods, we could finally conclude that the wave boundary layer model is performing the best. And next to that, the Gislemat method was performing well. With all this, we did the exercise. It is fine. So next what? So this is, I'll skip this. This is again some comparison at deep water locations and wave rider buoy at Pondicherry and so on. So we are comparing the significant wave heights, not only the water levels, we are also understanding the waves and analyzing that. So I'll move ahead with this slide. Again, similarly here, we did another exercise to understand what is the impact of the waves that are coming from the southern Indian Ocean. So basically, you can put it in the other way around. That is basically wind sea and swell impact. So when there is wind sea during cyclones, the wind sea impact will be there only in this region, but the swells are also going to come from the southern Indian Ocean. They are also going to interact with this. So how they impact the overall wave heights, wave direction, and so on, that also we investigated. So what we observed, or what conclusion we arrived at, is that the pre-existing wave climate, or the sea condition and swell conditions from the larger domain must be accounted in the numerical modeling of storm surge. And this is important when you are looking at the. Yes. Is somebody telling something? Yeah. If you are not telling, then let me continue. We need to look at that when we want to focus on the wave characteristics. Let us say you are designing some structure along the coast or in the offshore region. And for that, the wave height, wave direction, wave period, everything is important. And during a cyclone, if we don't consider the ambient or pre-existing wave climate, these outputs are not going to be correct. So those who are planning to do that, you need to remember that you need to consider the pre-existing wave climate whenever you are simulating the cyclones. Only cyclonic simulation is not going to give us the wave characteristics during that time correctly. So as I told that this kind of numerical modeling we cannot do for real-time forecasting or warning systems. So what we need to do, we need to develop some kind of wind drag formulation. So that is where the exercise started. We started developing one improved wind drag method by which we can use it for the real-time forecasting. In this case, what did we do? We considered 30 different cyclones. And if you see, all these 30 different cyclones pertain to different ocean basins. So obviously, we have taken slightly more number of cyclones from the Arabian Sea and Bay of Bengal basin, but we have also included cyclones from other ocean basins so that the formulation that we derive is generic and applicable anywhere across the globe. So looking at these 30 cyclones, it is not only different ocean basins, you can also see that different intensities are also considered. So if you see the different intensity, we have considered the 3 cyclones in the range of 30 to 40 meter per second wind speed. We have considered almost 12 cyclones in the range of 51 to 60 meter per second, and 6 cyclones, let us say, from the range in the range of 70 to 80 meter per second, and one which is basically the super cyclone category and above. So we have considered different characteristic of these cyclones, and that is basically representative of a wide range of cyclonic wind speeds, so that the formulation can be applied to any cyclone that is going to come tomorrow. By doing this exercise, what we arrived at a third order polynomial, and you can see here this third order best fit is showing the correct or most accurate profile to this data set or the black dots that you can see. What are these black dots that you see here? These are the drag coefficients with respect to different wind speeds. And how did we get these points? We did simulations. As I said, we considered 30 cyclones. So all these 30 cyclones we simulated in their ocean basins, and we carried out the study using this wave boundary layer model, which I discussed. And then we got the drag coefficients from this analysis. And if you see, one cyclone will have its own radius of influence, and different places will have different wind speeds. So for all that, we collected number of points, more than 100,000 points, or you can say 1 lakh points were considered. And with that, when we did this analysis, we could find that this third order polynomial is the best fit. And that matches with some observation, which I will highlight here. You can see here this pink color dots that is given by Powell. So this Powell study is one observational study. So during a cyclone, they did some kind of measurements by taking flight paths to the cyclones and sending some sensors, and they collected this data. And from those data, they derived wind drag coefficient. So when they plotted, they found that it is neither increasing linearly nor it increases and have a cutoff value. Rather, it is increasing gradually and then it is reducing after some time. Now, the same pattern is also observed when we considered the process-based modeling, and we found that the drag coefficient is increasing up to certain wind speed and then it is decreasing. So more or less we found that our study or our analysis is following the observations and it is completely improved considering the other formulations which were given earlier. So this formulation what we have mentioned here was given as improved wind drag method, and this is the method which is empirical relation can be straight away used, and we can go ahead and do the simulations and find out our surge values which will be more accurate. So that is what is the contribution we have done. So in the similar lines, people can take various other aspects which are there still to be improved in this terms of modeling, and they can also come up where this kind of forecasting and warnings that are given will be improved, and the government as well as the authorities can act more precisely. All right, so I'll keep moving on that. So we did apply this improved wind drag method for a couple of cyclones in different ocean basins, and we found that they are really performing well, and the computational time required is also very, very less. So this is something you can see here, the computational time required considering the with respect to the detailed numerical modeling is more or less 2.5 times less, and that is what is a significant achievement in this case. Now, let us move on. In the same topic of cyclone modeling, we also investigated the impact of cyclones when it approaches a certain coast. So this is all about the physical process in the deep sea, that energy transfer from the wind to water and so on. But now the cyclone is going to propagate and it will reach the coast. When it will reach the coast, it will propagate over the ocean bathymetry or ocean bottom profile. So this bottom profile can vary. Let us look at that. You see this cyclone track 1, what we have taken the Thane cyclone and we have changed it. Basically, we have changed it to different angle of approach. So the cyclone 1 is approaching at an angle of 45 degrees to this coast. Here it is approaching with an angle of 75 degrees to this coast. And here it is 90 degree, 105 degree, 135 degree, and so on. So now all these different approaches, if the approach changes, what will happen? If you look at the seabed profile, it will also change. So now if you look at the transect 1, which corresponds to cyclone 1 track, and similarly cyclone 2, 3, 4, transect 2, 3, 4, and 5. So different tracks, so different bottom profile. Now it is evident that when the cyclone is going to ride over different bottom profiles, the deformation or the process or the changes in the surge characteristics are going to be different, and that may lead to higher surge or lower surge. That needs to be investigated. That is first. Second, what we have considered here, the coast around Chennai is kind of a concave coast. So you can see the profile here. It is a concave coast. Now, if the cyclone reaches towards a concave coast, the energy concentration would be different if it is going to reach towards a convex coast. So in this particular study, we analyzed the concave coast and tried to investigate how the flux is going to be moving, or the momentum of mass flux and momentum is going to move in this region, and how these dynamics are going to change. And because of that, what will be the surge? So eventually, in this paper, we could conclude that the maximum storm surge inside a concave coast is going to occur for cyclones with an approach angle of approximately 75 degrees. So that is for the east coast. Now, if you go to west coast, accordingly, you have to again investigate that and find it out, because the east coast, the continental shelves are the width of the continental shelves are narrow. So with a short span from the coast to towards the sea, the depth is going to suddenly increase. Whereas along the west coast, you have larger width of continental shelf, which can vary up to few hundreds of kilometers. Now, that can also completely change the overall picture that we see. So that is why this kind of studies have not been done for convex coast. This kind of studies have not been done for west coast, but some studies have been done for different width, continental shelf widths. But still, further more studies are required in this direction. So those who are interested, they can take up such kind of studies. This is another study which we carried out to understand the effect of cyclone intensification on storm surge. Let us say one cyclone is going to intensify somewhere in the deep sea, and another cyclone is intensifying just before it is going to have a landfall. So they will have completely different impact. And if the intensification that happens is going to sustain for 6 hours, or the intensification is going to sustain for 12 hours, 24 hours, so that duration is also going to affect. So we also analyzed both these aspects, and you can see here that time from landfall, the landfall time in hours, where the intensification takes place, different scenarios are given. So there are just instantaneous intensification, or a kind of intensification over a long period of time. So both the scenarios were considered, and this was analyzed. And the results I am not going to go through in detail, but what we concluded from this study is that if you have some intensification which is going to be very close to the continental shelf, then that will have higher impact. So similar studies, as I'm telling, so I'm giving some of the information where we have taken different parameters and try to understand. So one can again take similar other parameters and investigate and improve on the results, so that it will be useful for the coastal population. Eventually, whatever we do, the final target is how we can help the coastal people and the community. This is another study where we carried out the storm surge modeling and forecasting along the east coast of India, and we prepared various flood maps. So, considering the climate change scenarios, we have different. When we carried out the study, there was RCP scenarios, but now the scenarios are being called as SSP, so shared socioeconomic pathways. So the RCP scenarios, what we considered are RCP 4.5 and 8.5. RCP 4.5 is the moderate climate change scenario. 8.5 is the extreme climate change scenario. So as per the literature, one can increase one is expected, or the wind speed is expected to increase by 7% in this moderate climate change scenario. And wind speed is expected to increase by 11% in the extreme climate change scenarios. So in both these cases, what did we do? We considered some cyclones approaching the coastal locations. Let us say this is one coastal state I am presenting here, is the Odisha coast. So you have one point here at Gopalpur, Puri, there is one Devi River location and Vitarkanika location. So these locations are considered as landfall locations. Now, if the cyclone landfalls at Puri, then what will happen? If the cyclone landfalls at Devi River, what will happen? So we analyzed various scenarios, and we also considered different cyclone intensity with RCP 4.5 and 8.5. So with that, we created this kind of flood map. So as you can see here, this is the landfall location map, and here this one is extremely severe cyclonic storm that we considered, which landfalls at Puri. Now, if the cyclone landfalls at Puri, then this will be the area which will be flooded maximum. And this is the flood map that you can see here. In the regular current scenario, if the wind speed is going to increase by 7%, that is RCP 4.5, then the flood intensity is going to increase up to this extent. And you can clearly see the extent or the area has increased just by increasing the wind speed over 7% increase of wind speed, which is going to be RCP 4.5. Now, similarly for RCP 8.5 scenario, this will be the flooding scenario. You can see much larger area is going to be flooded. So this kind of maps are going to be useful for future planning and preparation purpose, because it is inevitable that the cyclone intensities are increasing. And if the cyclone intensities are increasing, some of the flood maps or flood prone zones we need to identify. So we have to carry out such kind of studies for different regions with suitable accurate models. So you have already seen the modeling approach, the models that we use, and different ways that we do the analysis. And then one can prepare such kind of maps, which will be useful for the various government agencies. This is another map which basically shows the landfall at Gopalpur. The earlier one was at Puri. This is a super cyclone landfall at Gopalpur. Then this is extremely severe cyclone landfall at Puri. This is again super cyclone landfall at Puri. So different intensities of cyclones and different scenarios are analyzed. All these maps were provided to NRSA, National Remote Sensing Center in Hyderabad. So I'm sure they are making use of these maps for further use. This is the landfall at Vitarkanika. So how the flooding and inundation is going to change, and that is also mapped. In addition to that, we also carried out another study which I would highlight, that the cyclone shelter location identification and design based on the vulnerability. So when we talk about cyclone shelter location identification, it is a very complicated process. It involves a lot of information. Just to quickly give you in a nutshell, first of all, we need to analyze what is the cyclone storm surge along the coast, up to what distance it will inundate and what will be the level of inundation or water level in a depth at different locations. In addition to that, we have to take the road network. We have to consider the water body network, because when you have a cyclone shelter, which is meant for people to be sheltered during a cyclone, what you need to ensure that people reach that location very quickly within short span of time. So the proximity to that shelter from their location needs to be analyzed, and that proximity is not by straight line. It is by the road network that you have. And if there is a water body cutting across the road network, you have to also account that during a storm and cyclone, there might be a possibility that the water body might be overflowing and your road that is available will be blocked. So how do you reach that? So all these aspects are considered. Then the population, then there are several guidelines which are laid out by National Disaster Management Authority. So by considering all that, we have developed some algorithm, and based on that, finally we derived the cyclone shelter locations which can be which were identified, and finally how many number of cyclone shelters are required we calculated, and we did not stop there. We also prioritized based on the vulnerability zone, population, and so on, which cyclone shelter can be constructed first and next, and so on. So on a priority basis, each of the cyclone shelters were also listed. So it was a huge exercise that we carried out over a period of almost 2.5 to 3 years. and the detailed reports were submitted to Odisha State Disaster Management Authority. This work was done for the Odisha State Coastal Region, so it was submitted to Odisha State Disaster Management Authority. We also gave them a suitable design, complete structural design and layout of a cyclone shelter, which can accommodate maximum number of people during a cyclone. And that also considering all the aspects of physical mobility and all requirements during cyclones, the flood level, maximum flood levels, and so on. So these are various works that we can do and reach out to the public to support them. Now, this is another one which I was also hinting in the beginning. There may be certain installations, coastal installations, which are considered as high-risk coastal installations. Typically, let us say I was talking about the nuclear power plants. So in case of a nuclear power plant, which there are a number of nuclear power plants along the coastal locations, and you don't want any kind of damage to the nuclear power plant. Typically, they are designed for very high return periods. Some of the facilities in nuclear power plant are designed for 10,000 year return period. So when you are talking about 10,000 year return period, the values that you consider are very, very high, and the safety measures that you take are very high. So this is one study that I'm just discussing, where it was required that there should not be any kind of overtopping even during the cyclone. That they will have some kind of protection wall, and there should not be any kind of overtopping during the cyclone. Forget about the normal scenario. So now, for that, what we did, we designed some kind of seawall protection, and on top of that, also we designed a crown wall. And the crown wall, we considered some kind of curved wall profile. There are a number of different shapes of crown walls or curved seawalls profiles available, vertical profile available. So we considered all of them, and we found that none of them are really working. Then we worked and designed a profile with a lot of trials, and finally we came up with a profile which is workable and which shows that the overtopping can be completely stopped, or it will be zero with this kind of profile. So finally we suggested that the vertical seawall with a crown wall with this kind of forward backward 2 radius profile that can be adopted, and all the specifications for this 2 radius profile are also given to them. So now this kind of studies, this kind of analysis are required where there are practical requirements by certain people. Okay, so now quickly moving on to another research aspect. When we talk about coasts, the coastal protection is not only with hard measures like seawalls or so. There are also requirements where we have natural protection to be placed so that we can safeguard the infrastructure and facilities behind these natural barriers. So that we call it as coastal vegetation. The coastal vegetations are in many ways. There are different types of coastal vegetation. As you can see in this figure, there are coconut trees. This can be a set of coastal vegetation. You have mangroves along the coast. They are also coastal vegetation. You have some kind of different types of grass and other plants which are also used as coastal vegetation. So different coastal vegetation have their different properties. So one can study the impact of this coastal vegetation on this extreme waves or events. Let us say there is going to be a SARS or tsunami. So how we can protect the coastal regions by such kind of vegetations. So this is one study where we carried out the impact of debris. So as you can see in this numerical simulation as well as this experimental work, there is a debris which is allowed to float under this surge or the tsunami kind of flow, and that comes and impacts a structure which is going to be there along the coast. Now, most of the times our design codes, whether you consider Indian codal provisions or FEMA, which is the US code, none of these codes have considered the debris laden flow and its impact. So most of the times it is only the hydrodynamic load due to surge that is considered for design of structure. But whenever there is an event like this, it is also going to carry a lot of debris that comes along with it. If that carries the debris, then the force is going to be higher or lower, or what will happen if this debris comes and accumulates in front of the structure, or all these aspects needs to be investigated. So what we did in this direction is the preliminary work. So first of all, there were no experimental study available, and the numerical models were not available, which can really simulate the debris dynamics. So what we have done, we carried out this experiment in the kind of a glass bloom study where we simulated this debris flow, and we also measured the force on this structure. So we installed some kind of sensors, 6 degrees of motion sensors and load cells, which measured the movements as well as loads that are coming on this structure. And we also installed the accelerometers in this debris so that we can track the debris movements and find out with the kind of flow how the debris is going to behave and move and what will be the impact of that. So all this we did measure, and then we recreated the same using some model that is called smooth particle hydrodynamics, SPH, and there is another coupled model with the DVI, SPH DVI model, which we used to simulate this floating debris laden flow. And that we analyzed how the impact on the structure is going to be. So along with that, what next we did, we created in the model, we created some vegetation. So you can see here, this is a model and this is a container, and this is the flow that is coming from this side, left side. And if the flow comes from the left side, it crosses this vegetation. And once it crosses the vegetation, the flow characteristics are going to change. And then how this flow, changed flow or altered flow, is going to carry this debris, and then how that debris is going to impact the coastal structures. So basically, the impact of coastal vegetation on this flow as well as debris and the impact on the coastal structure was analyzed. So different kind of configurations, different vegetation characteristics can also be considered. So this, I will tell, is a preliminary work that we have done. There are a lot of work which can be done in this particular area. One can consider different type of vegetation. One can consider number of debris, because when debris comes, it is not going to be a single debris. You will have different debris, and the debris are not going to be of same specification. Let us say what we have simulated is a container, but every time it's not going to be a container. It will be a container, some other, let us say the car was there, it will be floating. Some other debris that is from the broken buildings can also be carried along with that. There could be wooden logs. Anything could be debris. So now different aspects, ratios, different dimensions, densities, all that can also be studied. So a lot of scope is there in this direction for people who are interested to take up. So now let me move further. This is again another simulation which I am showing. I will move on. Another work that I want to highlight. Now the time is 12:30. So let me take a pause here. Maybe I will ask if there are any questions from anyone so far. Any participant, anyone?
Sir, we have put it in the chat,
kept
please.
in the chat box.
Okay, so I'm not looking at the chat box. So if there is somebody who is looking at the chat box, possibly can tell me.
Sir, there are few questions in the chat box.
Yeah,
So,
please, you can read out the question. I will try to answer.
okay. The very first question is, what are the softwares used on the site?
Okay, softwares used for what? I discussed a couple of modeling approaches. The first one, when I talked about cyclones, there we used AdCirc, that is called Advanced Circulation Model, and we used SWAN, which is basically a wave model simulating nearshore waves. That is SWAN model. And now what I presented just recently, that is this vegetation simulation. There we use this model called SPH-DEM, or initially we started with SPH-DEM, but then we moved to SPH-DVI. So what I suggest, those who are interested in getting further information about this model, so there is a paper which is published in this Applied Ocean Research, and the details about the model as well as the governing equations, the modeling procedure, everything is available there. So you can please first go through that. If you have doubts that further to that you want to discuss, I'll be happy to discuss. Otherwise, I'll also be happy to connect you to my PhD student who was working with me, Mr. Aditya Gupta. He is currently in the Georgia Tech University in US doing his postdoc, but I'm sure he will be happy to help you if there is an interest and you want to discuss further on that. So I have been actually highlighting the publications corresponding to each of those research. Those who are interested, you can go to the publication. That is the best way. You can go through the publication that will give you further more detailed information. And then you want to discuss, you please get back to me. I'll connect you to the right kind of people who will be able to spend time with you and help you. Or I will personally myself will discuss with you to give you further information and details. Okay. Yeah. I think I answered that question. What is the next question?
Yes, sir. The second question is whether this model is site specific or a general purpose model.
No, all these models, whatever I have discussed, they are not site specific at all. They are generic models. They are adopted all across the globe. And when you go to site specific, you have to use the data. So let us say we are doing a cyclone modeling. We'll use inputs. So input is going to be bathymetry data. Input is going to be topography data. Input is going to be wind conditions. So they are going to be site specific. But the model is not site specific. All these models are generic models. And there is one small catch here. When you take these models, there are some parameters like bottom friction coefficient. The bottom friction coefficient could vary from site to site. If you have a coast which is a sandy coast, if you have another coast which is a rocky coast, the bottom friction could vary slightly. So that is where we do validation. So what we do a study for some past event where the observations are available, and with all the forcing everything correct, we do the simulation. And then if there are some minor or small differences, we try to adjust or tune our bottom friction coefficient or some factors like that, so that we represent, because you may not be having time and resource as well as expertise to go measure different physical processes and establish your bottom friction coefficient for a particular coast. If people have already done it earlier, some studies have already done and worked for that reason, they have reported these values, you can straight away go ahead and use it. If not, then you have to calibrate your model. So that part you have to do to make it site specific. That's all. Yeah. So what is the next question I would prefer to take?
Sir, the next question is how likely the concave coast gets cyclones as compared to other coasts?
Okay, this is a very tricky question, I would say. See, in general, the coasts that are See, we are talking about cyclones. Let me quickly take you to the slide where I am talking about cyclones or the concave coast. Where is it? Where? Here. So we are talking about concave coast. Okay. So it is not necessary always that the cyclone is going to come and hit a concave coast. It depends on its track, and the track is driven by the atmospheric circulation, which is the more predominant. So atmospheric circulation is going to drive the track. Now, where the maximum surge is going to happen, that is what is more important. So let us say I have this, I'll take you to this figure. If I have the cyclone which is coming and hitting along this point B from the direction 75 degrees. So what will happen? The cyclone is going to rotate in the anti-clockwise direction. This characteristic, I hope you know already, that the cyclone, what is that? The rotations are anti-clockwise in the northern hemisphere, and the cyclone rotations are clockwise in the southern hemisphere. So why it is and all, I will not get into that right now. But let us go ahead from here. So now the cyclones are anti-clockwise in the northern hemisphere. Now, if the cyclone is anti-clockwise, which is moving like this, then what will happen? When the cyclone moves like this, you can see the wind speeds are also going to move according to that. Let me take you to some picture, if at all I have. I don't think I have some pictures of wind speed vectors. Anyway, it doesn't matter. Now, this is the cyclone track. Now, along this track, the wind speed is going to move like this. So on the upper side, that is right side of the track, you have the wind speed, which is pushing towards the land. And on the left side of the track, the wind speed are moving away from the land. Now, you will be able to tell me positively that the wind speed that is moving towards the land will create surge, which is going to be higher on the land, and the wind speed which is moving away from the land, which is going to pull the water or have a negative stress, will not create that much surge. It will only create some surge because of the overall flow or movement of water that is coming from the deeper side. Otherwise, in the look, wind speeds are not really aggravating the surge on the right side. Now, having understood that, now on the right side, you have a cyclone which is coming. You have the water mass that is being pushed towards the coast. Now, the water which is going to accumulate along this right side does not have much space to escape if it is a concave coast. And if it is a convex coast, it will have some larger space to escape. So that is why the surge is going to be higher if it is going to hit a concave coast. The surge will be slightly lower if it is going to hit a convex coast. That is first point. Now to the question that you asked, whether it will hit a concave coast always or not, that is not necessary. It is driven by the atmospheric circulation. It may hit concave coast, it may hit convex coast, but if it hits some coast, then as per that landfall location on the right side of the cyclone track, we can expect more surge compared to the left side of the cyclone. That is what is something we can remember. Okay, so I hope I did answer to this question to some extent. Next question I can take.
Sir, we have last question. Before that, we have got a positive feedback, which is interesting and informative for a marine engineer sailing in our Indian coast round the year. Regarding cyclone protection walls, I used to hear that naval vessels are kept as a fort-like formation before the breakwater in the entry to the port. This is the feedback. And the question is, kindly
Thank you
suggest
for the
good
feedback.
website. Yeah. Kindly suggest good website which can be downloaded for the forecast of cyclones in our coast, since we are always getting struck, though we have weather facts for every 24 hours. Thank you.
See, as of now, I would recommend that IMD is the best organization that provides us the information. And I have also seen over the last few years that earlier, long before, we used to feel that, okay, there is JTWC, which is a Pacific Ocean Basin warning center. They used to also give focus and data for us. But now IMD, India Meteorological Department, is the best organization, and their forecast is the best possible information that is available to us. What happens during cyclone? Yes, when the cyclone is approaching, when the cyclone is there in the deeper ocean, it provides a warning every 24 hours once. But as the cyclone starts approaching towards the coast and the intensity is increased, the warning or the bulletins are given every 6 hours once. So that is the maximum what we are getting right now. And higher frequency or higher time interval information is not being given so far. And there are a lot of private organizations who are giving such kind of bulletins, but they all depend on the information, source information from IMD. So I would not go to anyone else other than IMD for such kind of information. And this information is available in the IMD website itself. And if you want, there is something called RMS or RSMC something. I think if you go to IMD website, you will be able to get the link to the cyclones, and each individual state, coastal state, has one office of IMD, which are basically tracking the cyclones at the real time, and they are giving the information. They also release the bulletins. So eventually, all the bulletins you will be able to get from IMD only. Okay. And
Thank you, sir.
for-
Sorry to interrupt. Yeah,
Yes,
Ramkrishnan,
please.
marine engineer. Thank you very much, sir. Yeah, very interesting. Mr. Krishnamurthy from Andaman. We are CATNs,
Yes.
so he has introduced very interesting. Actually, because we are a small ships going on coastal chemical tankers. The last one which you said, that hemisphere, northern and southern, maybe a very basic in the cyclone tracking, but you won't know. Sometimes the master, if he is very young and all, they take inside only, like without considering how the direction is going. We all got stuck one time also. We went into the
Oh, my.
center. Company called us, hey, get out and all. Like, so always our coast, especially Bay of Bengal, is a real. All the cyclones we have met, sir. Thank you very much. Very, very interesting, sir. Thank you very much.
Okay, thank you. Thank you so much for your input and feedback. And I'm really happy to hear back some statements from you, and also want to inform other participants who are possibly not like me, who are not the people who present inside the sea. It is not so easy for the captains and the chiefs to masters to sail the boats or vessels inside the sea. They face lot of difficulties, lot of challenges, and they are always at risk. So I always appreciate, and on this aspect, if there is something that the Navy or the Coast Guard they need, that okay, certain cyclonic events you need the higher or better focus, we can possibly discuss that, and that can be done as a separate development with association from IMD as well as inquiries. But that can be done specifically for the vessels and naval bases. But for the local public, I think currently whatever we have are really working good. But wherever required, we can do that.
Thank you very much, sir.
Thank you. Thank you so much for the feedback. Yeah. So is there any other question that we will take? Otherwise, I will proceed with the talk for another 10-15 minutes.
Yes, sir, you can proceed. We are done with the questions.
Okay. Thank you so much. So let me now move on to the next part. So I did spend quite a lot of time on the cyclones, but I'm happy that it is really appreciated. And now, this is another study which I will quickly highlight, where we try to understand the climate change impact on ocean waves and the coastal stability. So first part is climate change impact on the ocean waves. So what we did a large scale modeling where we considered completely southern Indian Ocean, that is from minus 60 degrees south to plus 30 degrees north. That is considering Indian Ocean, complete Indian Ocean basin, Bay of Bengal, Arabian Sea. And we did wave modeling. And with that wave modeling, we validated our model with the buoy observations in the deep water, that is at AD07 and other deep water buoys. We also validated our results at the wave rider buoys at different coastal locations. Then once we have the validation done and we got confidence of our results, then we collected the output from the model at various coastal locations along the coast. First, we did a very coarse analysis, and that is something I am showing here. And we did the wave forecast for the present hindcast forecast. That means for the past period, we validated. Then we took the same model and we forced future wind conditions to get future wave characteristics. So then we arrived at future wave characteristics for various locations. As we can see here, the future wave characteristics show increase in the wave heights, significant wave heights. And maybe I'll quickly tell that significant wave height is something that is a representative wave height that we always talk in technical terms. When you go to the sea, you see number of waves coming. They are of different characteristics. So what we do, we take wave height records for a large period of time, and then we take the average of highest 1/3 of the wave heights, and that average of highest 1/3 of the wave heights is considered as the significant wave height, which is used for various purposes. Any design, any analysis, that is what is used. So that significant wave height is considered here, and we found that in future, the significant wave height is increasing under this climate change scenarios. Now, it is not only wave height, the wave directions are also found to change. So I think that is hidden behind this, but wave directions are also changing. So if wave direction, wave period, wave heights, all of these are going to change, it is going to affect various aspects, including the coastal structures. If we have designed a breakwater at a location for certain wave direction, now in future, if that wave direction changes, then obviously the effectiveness of that breakwater is going to reduce possibly, or we may need to modify the alignment or orientation of the breakwater to some extent at that location. So it will have a lot of influence. The tranquility or the calmness inside harbors or ports are possibly going to change because of the change in the wave direction. And the sediment movement or the sand movement along the coast depends on the wave direction. So wave is going to create some kind of current. And if that current is going to be more aligned to the coast, then you will have more alongshore sediment transport. So that will create your longshore sediment transport. And if that is going to change, some places you may have more sediment movement or more loss of sediment. Some places you may have gain of sediment. So that will change the coastal stability. So all these things we did analyze. So after analyzing that, we prepared something called coastal stability maps. The first map at the bottom, you can see that map was generated by Central Water Commission, and they created this map based on the past data collected along various coastal locations of India. In our case, we did this study numerically. We got the wave conditions. Based on the wave conditions, using some approach, we carried out the sediment transport, and we found out what will be the stability conditions, whether the beach will be stable or it will be accreting or it will be eroding. So stable means not much change is going to happen in terms of the sediment movement. So the net sediment movement is going to be close to zero. If accretion, then the net sediment movement is going to be negative. So that means the sediment is gained there, and if the sediment is lost, then it is going to be erosion. So that we analyzed, and we prepared these maps for something near term, which is approximately 2040 scenario. This is 2070 scenario, and we have prepared this map on a larger scale. However, the same kind of studies can be carried out for separate coasts, because you cannot do that for a larger coast with very high resolution numerical modeling. So you have to choose specific coastal locations. You can choose a particular state or particular stretch, then you go ahead and do a fine resolution study to get such kind of outputs, and you can do the analysis, which will be really useful for planning of various localized projects and development. So at least on a broader scale, those who are interested can go to this paper and they can read this to understand more. So in this case, what we have used DHI Mike model for the wave modeling, and for sediment transport modeling, we have used some codes that we developed ourselves, which is based on the empirical formulations. And based on that, we have done these calculations. However, some of the other models which are available for wave modeling, one can use WaveWatt3, one can use one model. They are free of cost, and you can also carry out such kind of analysis and studies using those models. I will also highlight another work that we have carried out to understand the extreme wave impact forces on offshore as well as coastal decks. So basically, the purpose of this study is to consider the increase in the extreme waves. So over the period, we have seen that wave heights are increasing and the sea level is also rising. If the sea level is going to rise, then the freeboard or the gap between the water level and the deck is going to reduce over a period of time. And if that happens, on top of that, the waves that are going to come are going to be again much higher. Then there is a possibility that these waves are going to come and hit the decks with larger force and will have larger impact. So that is what is the idea behind this study. And we did numerical modeling using I'll skip this slide. So using a model called Reef 3D. So the Reef 3D model has different components. There are governing equations. It also captures the free surface so that we can capture the wave profiles properly. So with all that, I'll not get into the numerical aspect now. Maybe those who are interested can go to the papers and read that, and we can take another lecture completely separately. So with the numerical model, what we have done, we have simulated the extreme waves. So extreme waves, in this case, what we have done, we have created focus waves. So basically, when there are number of waves which will have the same phase, when their phase is going to match, there will be resonance. So resonance means there is going to be increase in the amplitude of those waves. So those freak waves or those focused waves we generated in this model, and we calculated how the impact is going to be on various structures. So this is a typical deck structure we considered, and we did simulations for various scenarios, and all these outputs we analyzed, and based on that, when we plotted the force, basically this is force divided by some parameters, basically that gives you the force coefficient. So this is going to give you the horizontal force coefficient. This is going to give you the vertical force coefficient. So that we derived, and based on this analysis, what we obtained these expressions which are there for horizontal force coefficient and vertical force coefficient. Now, this is research work. Now, what is the use for the practical engineers? Practical engineers don't need to bother about this numerical modeling, analysis, all that. What they will do, they will straight away take this. This is for solitary wave impact on coastal structures. So it can be used for tsunami. It can be used for some other type of solitary waves which are generated during some events, or maybe during some kind of cyclones or so on. Now, in this, what is required for the field engineer? Field engineer is required to find out what is the F, that is basically the air gap between the deck and the water level, and then the wave height. So now, if there are possibilities where we can use future sea level rise and calculate what will be the air gap for that, and we can also get the future wave characteristics, we can use those values and find out what will be the forces that will be on the structure. Once we get this coefficient, we can take it and use it in this expression, which is basically 0.5 rho. AH is the horizontal surface projected surface. C is the celerity of the wave. So these are easily obtainable. And once we get that, we can multiply that with this coefficient based on these parameters, and we can get the force that is going to come on this structure. So we will be able to get the horizontal force, we'll be able to get the vertical force, and these forces can be used for design of this coastal or offshore structure. Similarly, we did formulate this kind of coefficients for non-breaking focused waves. We also created and obtained the such kind of coefficients for breaking focused waves on the coastal structure. So this work is again available in this publication, and as I said, this is only done for this deck structures. There are a number of types of structures. We have considered only specific specifications of girders and so on, but one can vary these parameters. There are a number of scenarios. So scope is huge. It is only what you can explore. And in this case, we have used the model called Reef 3D. This is another work which we are working on now. We are evaluating the climate models everywhere. As you would have seen, our inputs are wind. So we wanted. Hello. Yeah. Mrs. Aboli, you are telling something? Okay. If no, then let me quickly summarize. So we are working on the wind speeds. That is the input for our all work. So when we are doing future analysis, future forecasts, or future projections, we are trying to find out which climate model outputs of wind is the best suitable for Indian ocean conditions or Indian conditions. So that analysis we have done, and we have also published that work in some papers. And we found that it is not all the models which are good. There are only few models which are really giving good outputs, wind outputs for the Indian Ocean region. So we should consider only those models or average of those models for our wind forcing for various numerical modeling work. So those who are going to use such future wind projections for their modeling purpose, they can possibly use this information from the papers that has been published. So that I will quickly skip. Okay, then this is another study which we have carried out to understand the coastal zone vulnerability due to sea level rise, which was supported by DST, Department of Science and Technology. And under that, we have analyzed if there is going to be sea level rise by 2050, 2100, and so on. So we have carried out different years of sea level rise, and we have analyzed how the low tide line is going to change, how the high tide line is going to change, how the tidal zone is going to vary at different locations, what will be the additional area which will be inundated due to this sea level rise, what are the low-lying areas which will be submerged completely under the sea level due to sea level rise. We have calculated this for all the coastal states of India, and then we have focused on specific locations along each coastal state, which are slightly highly sensitive and analyzed in detail. But still, we have done it as the overall work. We have created this framework. We have developed this methodology and framework for this work. Those who are interested can take this framework and further carry out localized studies and analysis for the sea level rise impact studies. That will be really useful, because there are a lot of locations which are there which are sensitive, and we need to evaluate the impact of sea level rise on those patches. There are wetlands which are available, and these are very, very important for us. We can analyze all that. So this currently what we are planning now is to take the next set of work due to sea level rise and cyclonic storm surge, how this coastal flooding is going to be and how the impact will be there on the coastal community. That is what we are moving towards in the near future. This is again the maps that we have generated due to this sea level rise impact work. We have seen what will be the extent of inundation at different locations and the area that will be flooded, and that we have also we are also going to merge it with another work that we have done on land subsidence. So if there is going to be sea level rise and land subsidence, both are clubbed together, the relative sea level rise is going to give us a clear picture. So the inundation in some area will be due to both. If the land is going to subside and the sea level is going to rise, so overall combination of this is going to give us a clear picture. So that is something we are also carrying out. So this work we are carrying out based on the satellite data we obtained, and we are focusing on Mumbai in the beginning. Possibly that will extend for other locations. So with that, let me thank all of you for patiently listening to my talk. I have exceeded my time, but I hope you enjoyed that. And if there are questions, I can take questions. There is no problem. For another 5-10 minutes, we can spend time. Mrs. Aboli?
Sir, it has been an outstanding session. Sir, it has been an outstanding session and lots of coastal engineering research you are doing at IIT Bombay. Really, I am fascinated to listen this. Really, thank you very much for this. It was
Thank
a
you
nice
so
thing,
much.
sir.
Thank you so much. So if there are any other comments, questions that we can take.
Sir, maybe
I
little
request
bit.
participants if you.
Yeah. Ramkrishnan, again, marine engineer.
Yes.
Is there any way to subsidize this? Any methods of spraying something like chemical or artificially? Like any measures can be taken to minimize by spraying something out of box thoughts, sir.
Yeah, minimize. I believe you are talking about oil spill.
No, sir. To reduce the effect of the cyclone, like when it is starting only.
Okay. So yes, I understand. There are a lot of work which is also starting. Basically, the energy, if we can dissipate in the atmosphere itself, or we can change the atmospheric conditions so that we can divert that or dissipate it. So there are two aspects to this. So you divert your problem to somewhere else, or you really dissipate that and solve the problem. So there are studies which are going on, and some countries are working on it, but it has not been really successful so far, and it has not been implemented as far as I understand. And second thing is the cost aspect to this. The cost is again another major aspect, because we have to spray something in the atmosphere using some flights, and then the scale at which we have to work, that is also going to be huge, because the cyclone, if we look at the radius of the cyclones, they are of hundreds of kilometers, and to spray something of in that scale is not an easy task. And what we are looking forward to is we can possibly change the track of the cyclone by changing the atmospheric dynamics. So basically, you have some kind of conducive atmospheric pattern that the cyclone is going to move towards, let us say, Andhra coast. So instead of that, you start turning the cyclone in the beginning, it will again move back towards, let us say, south towards the equator. So it does not come to a landfall location so that people can be saved. So that is something maybe on a possibility scale people are working on. But I am not completely aware of the work which how much it has been done in that direction, but I know that there is some progress which is being happening.
Great, sir. Thank you very much, sir.
Yeah. Thank you. Thank you so much for the question. So I'm happy that
Thank you, sir.
lot of
Sir, yeah, one more
Yes.
this, regarding this protection engineering, you said about the walls and all fantastic, because this Japanese we had the nuclear problem, no sir, that the nuclear reactor during
Yes,
tsunami and all. Yeah, so
right.
my friends are all in thermal power plant, this nuclear plant, also Kalpakam. So there is always inspection and like the emergency generator was located below the water level, something like that. So that was the
Okay.
problem in Japan. So they couldn't start. That was flooded actually. So they couldn't
Right.
give the water. That is way. But now our systems are all okay. That's what he was telling.
Yes. So this what I presented, I did not want to disclose the details of that, but this was done also for one of our Indian agencies and purposes only. This
Sir,
was done. Yes, sir.
one general question I will ask. Whether the floating breakwater is a reality till now, or it is just only for a very small wave heights?
No, it will be reality. There are some constraints to the floating breakwater, but it is also advantageous at many places. First of all, we have not thought about floating breakwater so far, but there are many locations where the wave heights are not going to be very high. You have lot of regions where sheltered waters are there, and you are still putting some breakwater for various reasons, or you can also putting floating jetties. So
That is okay.
instead
That
of
is okay. That is okay. Yes.
so if we are going to put floating breakwater, so what will happen? Floating breakwater, anything is moving, will have its wear and tear, and the more it oscillates, the more wear and tear will be there. Now, if we have a floating, let us say, breakwater along the open coast, so what will happen during monsoon? We will have strong waves, and at that time we may not be able to keep the floating breakwaters in place, so we may have to move.
Yes.
So there are two aspects to that. To safeguard the breakwaters or floating breakwaters, we have to tow it and keep it in some sheltered place and bring it back post monsoon. But now, if we remove the breakwater during monsoon, what will happen to the structures which were safeguarded by the breakwater during monsoon? So they will be impacted by these stronger waves. So now, how do we safeguard that? That is another question we have to also think. So that is
Yes.
why we have to make a deal between this. What for we are putting. If it is going to be some kind of a passenger jetty for which we are putting a breakwater, and during monsoon we can open the breakwater, passenger jetty will be still fine, and we can bring back the breakwater afterwards. Anyway, during monsoon, whether the breakwater is there or not, your passenger services are not going to be operational. So you may think of that, but
Yeah. Okay.
not everywhere.
Yes. I was talking about the eastern side of the Lakshadweep,
Okay.
where wave conditions are very, very strong.
Right. So that is something we have to look at the functionality of our facility, and then site conditions, and then wave characteristics. All that will decide what
Correct.
is possible, what is not.
Yeah. Thank you very much.
Yeah,
Yes.
sir, I was about to ask that because I was chief engineer in the last Lakshadweep passenger cruise vessel last
Okay.
Corona time. Yeah, really, we almost one day we were waiting. Morning we reached our mini koi, but there is no tugboat assistance, also no pilot. So we have to literally wait because the wind is so much. We are trying to go heading, but it is taking to the jetty straight away. So almost more than 12 hours we have to be in drifting. Like rail conditions in Lakshadweep is
I see,
yes,
sir.
yes, sir, yes, sir, yes, sir. But quite interesting, very wonderful. Your team, looking at your team, all smiling faces, all cyclists and civil, no, they are all doing PG, sir, or how?
Many of them are already passed out. They are working as postdoctoral researchers. Some
Oh,
of them are scientists, permanent
great.
scientists in UK government research
Wow,
organizations.
wow. Great.
Some of some of them are already faculty in NITs, and
Mm-hmm.
some have already gone to job, and
Oh, great.
some new faces have come to the group, which I have not added so far, but I'll
No,
possibly add it.
we could see the smiling faces. So your team is very happy. That I can give you guarantee. So you have a
Thank
very
you.
nice team, sir.
They make me happy. So,
Great, sir. Great, sir. But
thank you, sir.
any tie-up with the NIOT, sir? Do you need or
Yes, sir.
that is total?
Currently, we have a project with NIOT, which we are working on a deep water spar and semi-submersible platform to support OTEC platforms for energy and freshwater.
Oh, great, sir. And
So we
I
are
could
working
see
with
some,
NIOT.
yeah, please. Great, sir. All the best. And I could see NISC, National Small Industry Development Corporation in Chennai, Ekad Tangal. I used to see the graduates who are coming for their project works. Sir, I'm going to put the tsunami awareness boya. They're guiding, the gates are there. So it was quite interesting. Like students are also interested in all these warnings and they are doing the projects. They may approach you also, no, sir? Sometimes.
Yes, sir. Anytime, sir. Anytime. That
Very
is
good.
our job. That is our job, sir.
Great. Save us. You are the savior.
No, sir. We are just part of. We play that small
Mm-hmm.
role in that Setu construction. No, that's
Okay.
small.
I don't want to start that actually, as you are very strict and you don't want to deviate. I can understand, but we don't want to ask you also whether it is useful, why it is abandoned, and
That possibly we'll discuss at different forum.
yes, sir. Sure.
Okay.
But your presentation is superb, really. I have been presenting on so many sailing about 35 years and all. Now I am doing coastal for past 10 years. So
Okay, sir.
I know, sir, all we got stuck because we being engineers, we cannot go and ask them what is happening. Suddenly it will be calm. And we said, okay, and suddenly 250 miles and all, and small
Yes, sir.
ships, we have engine problem, purifier problem. Some more we have to manage. And you are
Sir,
only like,
sir,
yes,
I
sir,
sorry
please.
to interrupt.
Please
We
go
have
ahead,
to
sir.
move for the next lecture, so I would
Okay,
now
sir.
request you, sir.
Yeah. Thank you
Fine,
very
sir.
much, sir.
Thank you, everyone. Thank you for patiently listening. Thank you so much.
Sir, wait for a minute for the vote of thanks, please, sir.
Okay, sir.
Everybody
Thank you,
can
sir.
come on the photo, no, sir, video, so that you can take a picture, sir.
So I'll
Normally we
escape
do it.
my presentation. I'll
Mhm.
stop sharing.
Yes, sir, correct.
Normally photo section will be there. If you like, okay, go ahead.
Yes, sir. I don't have any problem. I'll be happy to
Yeah,
give a
please
smiling.
ask everybody to, yes, so that it can keep your memory. Great, sir.
Everybody may keep the videos on so that we can take a
Yes, sir, please.
picture.
I'm teaching in Maritime University also. So we know like people online courses, how the boys. Nice.
Thank you
Thank-
all. I now
Thank you, ma'am.
request Vanishri Patel ma'am to deliver vote of thanks.
Thank you, Aboli ma'am. I, Vaneshri Patil, Assistant Professor in Department of Civil Engineering at Dr. D.Y. Patil Institute of Technology, Pimpri, Pune, take this opportunity to deliver the vote of thanks for the program. On behalf of Civil Engineering Department, I would like to thank our today's expert for readily accepting our invitation for this interaction. I extend my heartfelt thanks to our management, Honorable Dr. P.D. Patil sir and Honorable Dr. Somnath Patil sir for his continuous support. I express my sincere thanks to our principal, Dr. L.K. Vadwasar, for his constant support and encouragement. I express my gratitude to Dean Academics, Dr. Urmila Patil ma'am, for her valuable guidance and motivation. I'm very much thankful to our HOD, Dr. Deepa Joshi ma'am, for the support and guidance she has extended to all of us. I'm thankful to all faculty members and participants for participating in this interactive session. Thank you, sir.
Thank you so much.
Yeah. I
Wish you good
request
day.
participants to fill the feedback link posted in the chat box.
Sure.
Thank you so much, and wish you all good day and have a nice session in the afternoon.
Thank you, sir.
Thank you.
Our next session will start sharp at 2 p.m. I request all the participants to join with the same link in time. Thank you.